Following from what we did in the last video, talking about LaTeX mathematics fundamentals, here our focus shifts to LaTeX mathematics symbols. I mean, we already saw some of those symbols in the last video, but here we want to look at them very comprehensively. Okay, so talking about LaTeX mathematics symbols, by the end of this section, you'll be able to use a wide variety of mathematical symbols in LaTeX, distinguish between text mode and math mode. Of course, you already know that. Uh, yeah, text mode and math mode, okay. Then correctly typeset operators, relations, arrows, accents, delimiters. Then you'll be able to format special symbols, e.g. for logic, calculus, algebra, sets, and geometry. Okay. So how do you get into the math mode? We learned that in the previous video. So you have inline format where you can just type your equation directly. So, I mean, something like this now. If I double click this and then I open, so I can refer to a previous Overleaf document we used without having to open a new one. Okay, let me bring this first. Yeah, good. So now, so if I open this now, we have, yeah, so from where we stopped, so if I need to do the whole, I mean, we can use either this or dollar sign, right? And then we have the equation rendered. So as you can see here, so we have the inline thing. The two of them do exactly the same thing. But if you want them, so this is inline now, right? So if you like, you can say subsection. Then I suppress the subsection number and I just say inline. Okay. So that already can go into the new page. So you can see inline here. But if I want it to be display, so you just do this. So for the display now, of course, we can have this square bracket, right? And then we close the square bracket. So that will go for display. So you can see that's displayed already. Then we have, this is no longer in it, this display. And then this is double dollar. So you see the two of them aligning like that. Okay. So they do exactly the same job. Okay, so back to this now. So we already know how to enter math mode. So taking care of both so I've taken care of both inline and display mode. So we talked about that comprehensively, but our focus here is to see some of the symbols that we always get to use in mathematics. So it's more about showing you those things and how to render them. So we did some of them in the previous video, like I said. So for the Greek letters, for instance, from alpha to omega, we have alpha, beta, gamma, delta, epsilon, zeta, eta, theta, lambda, mu, pi, sigma, phi, omega. I think there's also psi and all that somewhere. So you have the lower cases, you have the upper cases. So this is the command to render them. And therefore the command to render the upper cases now. So A does not have any special thing apart from the normal A. B is normal B. Then you have gamma, you have capital. So the gamma now it's capital G, then delta, and you have all of this. Then theta, same, lambda, same. So we have M, we have pi, we have sigma, phi, and omega. So I think I don't know where psi should lie. Maybe I would have taken care of that one. We can leave that out. So these are for the Greek letters now. So for the Greek letters, this is what you have. Then we move on to common mathematical operators. So of course the regular things you get to use. So if you want to use plus, you just type plus on the keyboard, that's for addition. If you want to use minus, you type minus on the keyboard, that's for subtraction. Then if you want to multiply, that's times, backslash times, that's for multiplication. Then for division, you just say backslash div, that's backslash div. So the beauty of Text Studio is that you can just click on all of these things here and they come out, they just jump out at you. Uh, you know, like all the plus, minus, everything is just there for you. So just click. So if you click, for instance, what do I want here now? Say, okay. To click, so the other type, in the other case, you said div, right? So if I bring this in, that just brings my divs. Then I just make sure it's between dollar signs because it's mathematics, right? So then you can run it and you see the whole division thing jumping out at you. So C dot if you want a dot product, then asterisk if you want asterisk, sec for composition, like uh composition of functions, for instance. Then plus minus, you have that. Minus or plus, you have that. Square root of x, you have it. Nth root of x. So in that case, now you specify the particular root. So if it's not just square, okay. So we also have relational symbols. So we have relational symbols. Say you want to talk about equal, not equal to, approximate, and things like this. So, and the things you should really pay attention to are these things now. The commands, you need to get them working. So you have this. For equality, just type equality normally. That's equal. Not equal to, you have backslash NEQ. So then approximately, you have approximately equal. So that's backslash approx. Then you have congruent to, that's this symbol now. So to get, you have backslash CONG. That's congruent to. Then equivalent or identical. So you have this three. So backslash equiv. Prop to, that's proportional to you have this now. So you have backslash prop to. Then similar to, so you just have backslash similar. You have that less than, you type less than directly from the keyboard. Greater than same. Less than or equal to, you have backslash LEQ. Greater than or equal to backslash GEQ. Then LL is much less than. GG is much greater than. So you can work around all of these things. So if we say, like, imagine you want to say 3 is not equal to 5, just to talk about that. Okay, let me go to Overleaf for that. 3 is not equal to 5. So here you just have to say that, so in dollar signs, okay, well, double dollar, that's fine. 3 is not equal to 5, okay? 3 is not equal to 5. So so you can see that here. See that right here. Then if you want to say 3 is less than 5, so 3 is less than 5, you just type it. Or if you can say 3 is less than or equal to 5, 3 is less than or equal to 5. Okay, already it's 57. 3 is less than or equal to 5. Okay, so you see that like that also. So all of these things can work for you. Okay, so what else? So if you want the arrows now, you want the arrows. Um, okay, most of the times they say something converges to something, right? So like something goes to something. For instance, okay, maybe you just have a question to find the, okay, or say evaluate. Okay, I think I like this. Evaluate. Then I want it to be displayed. Evaluate, let's say limit. Okay, we want to have limit as, so x goes to, as x goes to, uh as x goes to 0, right? For, they will now have dfrac as x goes to this, for x squared minus 4 all over x minus 2. Okay, so that will limit as x goes to 2, for instance. So we can have that. So this is how this comes out. So you see, this x goes to 2 now. Okay, this x goes to 2. See what it looks like. Limit as x approaches 2. So what I just needed to do was to say backslash 2, limit underscore x to 2, like this. And we have that. So look at this now. So these two, that's what we get. So left arrow, you have this. Right arrow, left arrow again. So but you see the R is capital now. So it means the arrow with the double line. Okay, so you have left, right arrow, that's if and only if kind of thing now. So, so I think when we did real analysis, we talked about things involving if and only if a lot. Like we say that uh, F is it right, left arrow, right? Right, left arrow, G. So that's F implies G and G implies F. That's what that simply means. So, okay, I didn't put it right, left arrow. Did I get that wrong? That should be left. Okay, that should be left, right arrow. Left, right arrow. Okay. Left, right arrow. Left, right arrow. Okay. I think that works now. So you see, no, left, right arrow. Okay, yeah, that's better now. So that F implies G and G implies F. That's simply what that is about. Okay, so you need up arrow, down arrow. So these are the commands you should focus on. So right arrow, left arrow implied by. So then left, right arrow, if and only if maps to, F maps something to G. So this is the kind of thing used for that. Then up arrow, down arrow, and all that. So arrows and their implications. Then we have set and logic symbols now. So for set, right, maybe you want to say A is in so letter X is in set. I mean element X, for instance, or let's say, okay, well, apart from this, don't forget you can also use this one. Okay. So we say A is in big A. Okay. So element A is in set A. Something like this. That's how that goes. Okay. Then so not in, so if you say want to say B is not in, so you can say not in like that. Then union, so A union B, all right. So A union B, that's cop for union, cap for intersection. So you say, we have that thing that okay, say A, so A cup, A cup, B, B, all right. How does that look like first? A cup B, right. Do I still remember int prime, A cup B prime, cap, say B cup C, something like this. So it's rendered, so you can have it this way, cup cap like that. Then there exists all this, the right arrow implies if and only if. So we have that also. You have empty set and so on and so forth, subset or equal, superset, and so on. So we have this set and logic symbols too. Then we can have calculus and analysis symbols, okay? Calculus and analysis symbols. So, I mean, see, we have partial. So if you want to say partial y, partial x, right? So you just come and you have, say, dfrac again. Dfrac. So dfrac. So you have partial. So partial y backslash partial x. Okay. So equals x squared plus y squared. So you just have, that's what you have. So see what that gives you. Partial y, partial x, like that. So you can do all this, the products of the series. Then you see this dy dx, that's frac dy dx. But if you now do dfrac, you see this one looks more legible than this other one. Then same for the partial f partial x, like that. Then contour integral, you have OINT. So a single integral is INT. Okay, I mean I can let me do that here. So for the integrals, now you just have int uh backslash iint, that's double integral backslash iint, okay, and then you can have surface integral oint like that. So you have all of these things working out that way. So if you want any of this, you can work them out. Okay. So you can do all this. So of course, single integral will be something like x squared dx. Double integral would be probably something like x squared plus y squared dx dy, right? And here, this one can be something like x squared plus y squared plus z squared dx dy dz. Okay, so you can have things like this. You can have this. So talking about, so single integral is like is that I think that's like a line or something. Yeah, that's like a line. Double integral is a surface. Triple integral is like a volume. Okay, so yeah, so we have all this. So all this sum for summation, prod, limit, I used that before. Infinity, I used that. I mean, you can use that to nabla for gradient and so on and so forth. So these are the calculus and analysis symbols. Then we also have the algebra and geometry symbols. So if you are dealing with angle, so angle 90 degrees, for instance, for backslash angle, that's for angle. For triangle, you just have backslash triangle. Parallel, you have backslash parallel. Perpendicular backslash perpendicular. You have congruent, you have overline, so AB, that's line segment AB. Then zero cap, that's hat theta, that's angle estimate. You have vector V. You also have bar X, that's mean of X. That's algebra and geometry symbols. Okay, so the key things is remember all these ones because this is how you can render them. Then we have accents and decorators. Okay, accents and decorators. I think we talked about them in the last video. So for X bar now you have over bar. For vectors you have vector arrow. For Y hat, that's hat and estimate. Then you have tilde F, that's tilde. Then dot X, that's time derivative. D dot, that's second derivative in the time domain. Then you have AB, that's overwrite arrow, that's arrow over text now. Okay. Now, like I said, if you come here, you have everything to this right side here. Okay. So you have all the symbols. So you have all the operators, relations, you have, this is all now. Okay. This is, so that miscellaneous mathematical stuff can use anyone you like. I think this WASism is for maybe, is it for, I mean, some other symbols like that. For chemistry, if you're into chemistry, I think I think it should be this WASism that chemistry people use a lot or something. I'm not too sure now, but I know there was a time I was interacting with these things and I saw that. So if you are into chemistry, you want to learn it specially for your own use. So if there's a chemist who wants to learn how to use this, you can let me know so I can do. If I have at least 5 people, I can do a video on how chemists can use LaTeX. Okay. So that this is talking about accents and decorations. So we can also have delimiters. We talked about delimiters in the previous video also. So you have the regular brackets. So A plus B. So to do that, just use normal brackets. Then if you want this kind of thing now, you need backslash this and A plus B like that. So this is different from well, I think this doesn't even make sense. We can do this directly, right? We can do this directly. I think that would be misleading to say if we do this and this, we have A plus B. I don't think this makes sense that way, actually. So it doesn't really make sense. So this one will just give A plus B. So in that case, now we still need to do the normal square bracket inside if we are going to use this. So it's more like that is like double dollar sign for sure. So if you really want to see this, you need to put it again. So I think this is not sufficient in this case. Okay, this is not sufficient in this case. So for this now, we still need this and this. Okay, still need all that because the backslash now is just to render it. Or better still, we don't even need, better still, we don't need all these ones. Better still, we don't need this because we don't have it for the others. So, and it can be double dollar or the regular backslash open square bracket, close square bracket. Then for A plus B now, because this is using braces, normally braces will not show, so we need backslash open braces backslash close. And for angle, we have left angle, you have this XY, then right angle, so that's R angle. Then for A over B now, so we have left and right. So left and right is very powerful. It's whatever, no matter how tall the equation is, left and right all automatically covers it with the proper delimiter, right? I demonstrated that in the last video. And then for this X now, I think something is not working well here. For this X now, we should have, so this, we should actually have something like this. I don't know why it's not showing properly. Maybe, I hope it works better now. So something is not right with this X. What can I do? Left, yeah, right. That should work. But it's okay. I mean, if it doesn't work, we know what it means, right? So this is X, and if we want to do norm, right? So left, V, right, this. Even this should be double of this now. Yeah, I mean, this should be double. It should be like double of this, I think. Yeah, I think that should be it. Now it's not showing. Okay. There must be something that is not working well here. But I mean, we know what we should do for that. So no worries. Mm, yeah. So use left and right to auto scale brackets to the content inside. So that's why you don't need all the BIGG, that's old school. So with left and right, you're good. Left backslash left whatever the delimiter is, maybe it's normal bracket, square bracket, whatever, just use that and you'll be good. Then this we have some special symbols now. So you have symbol like this RE now. That's RE for real parts of a complex number. Then we have this now, imaginary parts. That's backslash capital IM for imaginary parts of a complex number. Then Aleph in set theory. Bottom contradiction, we have this. Top for truth, we have this. H bar, which is reduced Planck constant, we have that. Then script L, that's L. And WP that we have stress P. We have the special symbols. I mean, from here, you have tons of those symbols. Like there are so many. You can work with anything you're interested in. Several of these things. So what I've even shown you, they are just the tip of the iceberg. Okay, so these are special symbols. So then we also have some modifiers and subscripts, like say you have A sub I, B sub ij. See how it's rendered, by the way. So you have A sub I. This quad is to give it space. So B sub ij. So if you have more than one thing that should be a subscript, you put them in braces without backslash, because the braces is just to collect them together. Then you have x squared. So you don't need for this x squared, then you don't necessarily need this one because it's only 2. So it will be fine. Therefore, y raised by n plus 1, you need the brace. For e raised by I over uh, I slash pi, you need the brace. Okay. So see, I times pi, by the way. So plus 1 equals 0. So that's how modifiers and subscripts work. So there are some useful shortcuts and tips too. Always use math mode for symbols and variables. So if you want to work with text in math mode, you need to put text something, something, something. Then don't forget to use packages like AMS Math, AMS Sim, AMS Font. So let me talk with this texting. Talk about this texting. Talking about text mode. You can use text mode in mathematics. For instance, let me say I have let me use a very good example. Talking about what is that kind of function called now? Step function. Okay. So let's say I have begin, open bracket, cases, like this. And then I have g of x equals g of x. So for begin cases now, begin cases, end cases. Okay, g of x should come before this, right? Okay, let me do this now. Double dollar. Okay, so I have g of x equals, then I can now begin cases. Begin cases, begin cases, and okay, end cases. Right. So we now have all those cases. Now let's say g of x is actually 3x minus 2. Okay, 3x minus 2 for, so now I want to type 4 as a word, right? So I have to put it in a text. So I say 4, okay, for say x, let's say for 0 less than x, 0 less than x, less than 7. I'm just making something up, by the way, so not to worry. Less than 7. So that's one of the cases. Now you can see the 4 is attached to everything, which shouldn't be, right? So I need like quad in front and after. So quad before the text and quad after to give space, and backslash quad. So you can see that separates it by the time it's run now. Okay, so you can see this works fine. So, but that's one of the cases. So if I need another case, say I need so if I need another case, I just come to do double backslash, go down, Control Z now. So come here now, and I'll say this is like say frac. Now maybe I even want to do frac. So I have 3x minus 4 all over 7x minus 2. Okay, for now we said this is from 0 to 7. So now this is from 7. Let's say this is from 7 to 14, like this. So that's another step. So now you see how this looks now. Okay, so you can see the 4 is what I'm emphasizing on. So the text looks normal. If I don't put it within this text bracket now, it is going to look like part of the equation. So if I remove this whole thing, so it's going to look, it is going to join up. It is going to look slanted or something like that. Okay, so now that I remove the text, so see when it's rendered again, it will change. So you can see looking like it's not looking good. So let me take it back to what it was. Okay, so let me do another case. Let me see. Finally, the case should now be, uh, so I'll just say this is X. So now X, I can just say otherwise, okay? So if it doesn't meet all the aforementioned conditions, then of course it will just be X now. That's for begin cases. So that's what we have in this case. So if you want to write, you can write text in a math environment. So just make sure that the text, you put it inside a backslash text like that. Okay, I've not done defrag. So if I do defrag here, this will even come out better. So I have defrag in this case. But I can even space. So when I have backslash like this, I can even have, I can give space. Maybe I can I can space things out. So I have 4 millimeters before the next one. So things can be more elaborate. So you can see the space is wider now because of the 4 millimeter I did after the double backslash. So you can do that when you have a set of equations even in matrices, you can create that space like that by putting whatever space you want after the double backslash. All right, so I think with this, we are good to go. We've come to the end of this interesting video talking about LaTeX mathematics symbols, and we have seen a lot of symbols. If you want to see some of these symbols the more, just go to Overleaf. I mean, what is it Overleaf now? Text Studio. Okay, just go to Text Studio and you find tons of these symbols that you can play with. Okay, so a whole lot of them, they are here all the way, so you can work with anyone you're interested in. Thank you so much for listening. Let me know how helpful this is for you. And if there's something else you'd like me to try out, feel free to let me know. If you have subscribed already, thank you so much. If you haven't subscribed, of course, you know you're missing a lot. You want to, and you don't want to. So subscribe and hit the notification bell so you can always get alerted each time a new video is released, right? Beyond that, you can actually become a member of this channel by clicking on join, and you see 3 levels of membership, and you can become a member of the channel, and we can, it gives you some special privileges to be a member. Beyond that, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing LaTeX right. Bye.